So in this video, we're going to talk about the different types of charging. So how we can, in different ways, create that positive and negative charge on different objects. So this is still, again, in electrostatics. So first, in order to talk about the types of charging, we need to talk about conservation of charge. So conservation of charge means that charges are not created alone, but in pairs. The idea is there are a certain number of protons and a certain number of electrons in the universe, and we cannot create any more. We cannot destroy them. Instead, they just move around. And so in electrostatics, it's the electrons that are moving. So in the example here of sodium chloride, this should be a very obvious example from chemistry. You have neutral sodium and neutral chlorine, where the sodium gives an electron. So why don't we draw that? So the sodium gives an electron to chloride, or to chlorine, making this chloride. So this one loses an electron, this one gains an electron. So this one loses mass, loses an electron, becoming positive. This one gains mass, or gains an electron, becoming negative. And the total charge of the two objects remains the same. So Na and Cl have a total charge of 0. Then Na plus and Cl minus have a +1, -1, so 1 minus 1 is still 0. So these two together make 0, these two together make 0. So total charge remains the same. So our first kind of charging is charging by conduction. And just like with thermodynamics, conduction means charging with direct contact. So the two objects must be touching. So in our example here, we have a negative object. There we go. So there's like a rod, and it has a negative charge on it. So it has extra electrons, and it comes in and it touches, this is called an electroscope. So what's going to happen is when this touches the electroscope, so let's extend it out here. So now it's touching. The electrons here flow onto the electroscope, thereby making this negative as well. So the electrons will spread on both objects. Both objects then become negatively charged. So we have a negative rod and we have a negative electroscope. And the way we know it's charged is, you see these two little things sticking down? Those are metal leaves. They have very little mass, so very little pull of gravity. And when they become negatively charged, when they become negatively charged, these are actually going to spread out. And that's because if this is negative and this is negative, they will repel each other. If it's neutral, they're hanging down. If they're both negative, they will repel. Now what happens if we have a positive object that comes in? So we have a positive rod that comes in. And the reason why it's positive is because it has less electrons. So this neutral object, plus minus, right? Equal number of protons and electrons, will give electrons to this positive rod. Well, what it does is it makes this positive rod a little less positive, but it still ends positive. And so here we have still a positive charge, but now since the electroscope has lost some electrons, it is also positive, and positive will repel. So whether it's a negative touching or a positive touching, the little electroscope will spread out. But what you need to really gain from this is charging by conduction requires direct contact. Charging by induction. This one seems to be difficult for students to understand, so I thought I would just try to draw out what's happening. So induction is charging without contact. And so let's say we've got our Van de Graaff generator here. And so the Van de Graaff generator is negatively charged. It gains a bunch of extra electrons, making the top of it negatively charged. If we bring in another ball that is neutral, so 3 protons, 3 electrons. If this is brought near it, this negative charge will push those electrons away. Okay, so let me draw the next step here. So negatively charged. And so when this ball is close but not touching, the protons are still in the exact same location. The nuclei of these atoms cannot move. So protons cannot move. But these electrons, because they're free to move, they're just floating around outside of the nucleus, they can move. And so the electrons are pushed away from this negative Van de Graaff. And so what it creates is this area here that's positively charged, so a region that's positively charged, and here is a region that is negatively charged. Okay, so let's go through that one more time. The negative Van de Graaff, when a neutral object is brought near it, the protons stay in their exact location. They cannot move. The only way you can move these is by a nuclear reaction, no big boom. But the freely moving electrons can be pushed to the outside. And since the electrons are now in a concentrated location, it leaves this side a positive charge and this side a negative charge. So only electrons are moving. So charging without contact. So there's charging by friction, and this is where you're rubbing 2 objects together that creates those electrons moving. So let's see if I can draw this. So here is a foot in a sock. Okay, so here's our sock on carpet. And so we're rubbing our foot back and forth. What we're doing is we're causing the electrons in the carpet, let's say. So this is positive, negative, positive, negative. So making sure it's perfectly even. What we're causing is, again, the positive protons cannot move, but the electrons can. And so as we're moving this back and forth, the electrons are moving onto the sock. And what that ends with is a negatively charged sock and a positively charged carpet. So friction, socks on carpet, clothes in the dryer, same thing happens with a shirt versus a pair of pants. They rub against each other as they're flying around inside the dryer, and this rubbing causes electrons to move from one object to another. The next one is grounding, and so this is where we're bringing in that idea again of a lightning rod. So grounding is adding an alternative path for the electrons to move. We want, eventually charge will build up. And even in electricity, when you have something plugged in, if it's a high enough electrical appliance, like a high enough energy appliance, it can just create like this pool of extra electrons. And so grounding keeps it from building too high. And so for grounding, let's see, you've got your 2 prongs here. That's where the energy is actually flowing. So you've got electrons and energy moving in and out, so creating a loop. This third spot right here, the kind of frowny face part of the outlet, is the ground. And what this allows is this extra charge. This extra charge, it gives an alternative path for it to flow. And that ground is attached to, you would guess it, the ground in your house. The way lightning rods work, remember they have two purposes. One is to prevent lightning from actually happening, but the second is if there is actually a lightning strike, so lightning coming in and hitting the lightning rod, it provides an alternative path for that charge to go back to the ground. So an alternative path. A real life example of this that you should worry about on a day-to-day basis is pumping gas in your car. Cell phones can have a charge buildup. Just sitting in the seat, you know, every once in a while you shift yourself in your seats in your cars. Well, that's friction. Your butt and the seat have friction between them. So there's a buildup of charge on your body. So here we go. Negative, 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 right? So we have negative charges on our body. Well, if you were to have this extra negative charge, and if it were high enough, and you were to grab the pump, there would be a spark that would go between you and the pump. And we have gasoline fumes plus a spark equals fire. Very bad. We don't want it to explode. We don't want anyone to explode. So an easy way to make sure that you do not have said explosion whenever you pump the gas is if you have this built-up charge on you, this takes, what, like half a second, is all you have to do is touch the side of the pump. So if you touch this side, it's made of metal. This is then attached to the ground, so all of your charges go to the pump, which then go to the ground. So that when you pick up the gas, then there's no spark, you don't have to worry about it, you pump gas and you're just fine. So all you have to do when you get out of the car, first thing, is just tap the side, and then you're good to go.